All right, so we're going to talk about typical reactions for different hydrocarbons, starting with alkanes. So alkanes are typically very stable, but heat or light can break these carbon-hydrogen or carbon-carbon bonds. Example where we see this is in combustion. Why does it keep doing that? So the type of reaction that we see for alkanes are substitution reactions, where if we have ethane in the presence of chlorine, if we apply heat or light to it, those chloro groups, it can substitute one of our hydrogen groups on ethane, and we result in chloroethane and hydrochloric acid. So substitution just meaning one of the functional groups are being substituted for another one. Alkenes, right? So whereas alkanes are typically very stable, alkenes are more reactive because that carbon-carbon double bond is a reactive functional group, right? It's what we call nucleophilic. And you'll talk more about that in orgo. Or maybe it's electrophilic. I don't remember. It's nuclear. It can, but what I just mean is that this can react with something else, and this meaning this bond can break easily. So that's the main thing to know. The addition reaction is the type of reaction we see for alkenes, addition reaction, where we're adding something, we're breaking this double bond and actually adding a functional group to each of those carbons. So each of those carbons now are connected to three atoms. But now we're going to add a fourth bond through this addition reaction. So in this example, we have ethene interacting with this dichloro, and we end up forming 1,2-dichloroethane because these two chloros get added to both carbons. So alkynes are even more reactive, and that should say alkenes. It's even more reactive than alkenes. So in a reaction with an alkyne, we react to it twice as much reagent as alkynes. So here's an example. We have ethyne reacting with bromo, and see, this is what we mean by twice as much reactant, because we are essentially adding two functional groups to each of the carbons that are engaged in this triple bond. So each carbon gets added or forms a bond with two bromo groups. Typical reactions for aromatic hydrocarbons. So these are usually substitution reactions where the hydrogens can be replaced anywhere on this ring with different substituent groups. There's like whole research just on this. Like, what happens when we explore different functional groups or the same functional group at different positions? That could literally be a whole PhD dissertation. So we have different names based on where these substituent groups are located, right? If we have a carbon um, substituent group, this is called toluene. Xylene, if we have two methyl groups at two different positions, if we have this ethene functional group, we have styrene. All right, so we're gonna pause here and then come back to alcohols.